Okay, so today we are going to start first with what? Last class trigonometry we have covered. So today we will start with coordinate geometry and wind up. Of course, there will be many things in coordinate geometry, but we'll try to write the important formulas and results. Derivations you will be studying in more detail in maths, right? So because it's basic maths, so how are we going to use in physics? That's what we need to see here. So let us go into the coordinate geometry. Coordinate geometry. Okay, so in coordinate geometry, first of all, we should know we are focusing on two dimension, 2D coordinate geometry. 3D coordinate afterwards we will see. XY plane it is. So there is a origin 0 comma 0 and any points can be represented by two values x comma y. What is x? X is the distance of this point from y axis. What is y? Y is the distance of this point from x axis. Okay, so this is what is y and this is what is x. Okay. This you can also say as y, x, and this also you can present as y. And this distance is the distance of this point from origin, that is r, right? This distance is r, and this may be having some angle theta, and this is right triangle, so definitely r distance of this point x square plus y square. This we have seen many places in vectors, right? Everywhere we have seen that coordinate geometry. So x is called abscissa, and y is called ordinate. Ordinate. Okay, abscissa and ordinate. So any points can be represented by these two values, abscissa and ordinate. And you know directions are there. So in this coordinate, x is positive, y positive, so both are positive. Here in the second quadrant, x is negative, y is positive. Third quadrant, x is negative, y is also negative. Fourth quadrant, x is positive, y is negative. Right? Those things are, of course, you know that. And any point on x-axis, if you take any points on x-axis, its y coordinate will be definitely 0 because it is lying on the x-axis. Any points on the y-axis, it's have x coordinate as 0, y will have some value, right? Here also some value will be there depending on where that point is. Okay. So x coordinate, y x axis, any point will have y coordinate 0, and on y axis any point will have x coordinate 0, right? So that's what you know. Then what else we know? What do we need here? Here we need some important point like distance point formula, right? Distance point formula you have studied. Distance formula. Distance formula. So actually it is not distance, it is displacement formula. Displacement formula. So in between two points, let us say this is x1 comma y1, this is x2 comma y2, right? What is the distance between these 2 points? That means this straight line distance, that means it is displacement. So that we can very easily calculate because this is delta x and this is delta y. And this is what is displacement delta r. So delta r is nothing but root under delta x whole square plus delta y whole square, which is root under y2 minus y1 whole square plus x2 minus x1 whole square. Okay, that's what it is. Distance or displacement. Then let's go to next. So here I will see, I will also give so many applications of that. There are many applications which are useful. We will see all those things. Okay, then next let us go into next. What is the meaning of slope of a straight line? So now first topic we are going into straight line. Straight line. Straight line. In a straight line, what is the meaning of slope? Slope of a line. slope of a line. So suppose that there is a line like this, right? And this is x-axis and this is the angle theta. So this tan theta is called slope of line. Slope of line. Note that this angle theta is measured anti-clockwise. Suppose this line is making angle from this side. Let us say this angle is alpha. So that slope we can also write as minus tan alpha. Minus tan alpha. Hmm? So that means if you are measuring the angle from positive side, that means you have to write plus tan theta. From this side, if you take, that is, sometimes it is convenient. Why it is convenient? Suppose, for example, a line makes like this way, right? And suppose this line with x-axis is making acute angle from this side. Let us say this is 30 degree. Then it is better to write the slope of this line as minus tan 30 degree, and we can write minus 1 by root. Right, it will be better to use this way. Right? Slope can be written like this. Anyway, next thing is that we want to find out equation of a line. How is a line defined? A line is the local line, means a straight line. Straight line, a straight line is the locus of a point which moves in such a manner, in such a manner that its slope remains constant. Its slope remains constant. That's how a straight line is defined. For example, a straight line, let us say for example a point is moving like this way. Maybe an ant or insect or something is moving in such a manner that the slope of this curve remains constant. So slope means, suppose if you take for example this point. Slope, I think you remember the concept of slope in dy by dx is what is tan theta, right? Dy by dx is tan theta. So if you consider the slope of this graph, yes, slope is that only. Slope means for a straight line we define slope, but for a curve, in general curve means any point you take, any point you draw tangent. That tangent, tan theta, that is what is slope. Slope at that point. Locus, locus means it is the path. Path. Locus means path. Locus means it is the path. So suppose a point is moving such a manner. Suppose a point moves like this. Suppose a point moves on this curve. Then it is not having the same slope, na? Because when it is here, slope is changing continuously here, right? Slope is changing. So the path, what is moving is in a path so that its slope is always constant. Here, for example, if you take slope here, slope means draw tangent here. When you draw tangent, if you take this point, when you draw tangent here, if you take this point, you draw tangent here. If you take this point, draw tangent. It is the same straight line, you see that, because this angle theta is going to be constant. But in this case, if you take slope here, if you take slope here, if you take slope here, thetas are different, right? These are different angles it will form. So this is not a straight line, but this is a straight line because slope is everywhere same. Clear? That's how this straight line is defined. Okay. Now going into the concept of equations of a straight line. So what is meant by equation? First of all, equation means it is a relation between x and y. Suppose this is the graph for any curve. It is, take any points, any point x and y, any point on this. So relation between x and y. That relation between x and y is the equation. Okay. Relation between x and y. This relation between x and y is the equation. So now coming to this straight line equation, because its slope is constant, so we can say dy by dx is constant. Dy by dx is constant. Let us call this dy by dx as m. Let us call this dy by dx as m. Okay, dy by dx. Let us call this as m. Now we will write dy is equal to m times dx, and let us integrate both sides. So if I integrate y, this will m. Integration of dx will become x plus a constant. We are adding this constant is called constant of integration. You know, in indefinite, right? Indefinite integration, constant of integration. Constant of integration. So that's the equation. Y equal to mx plus c is the equation of a straight line. Now if I try to plot this equation on this graph, xy graph, if I put x is equal to 0, then y will become equal to c. That means x is equal to 0, y is c, right? And if I put x0, sorry, y0, so x will become minus c by m. So somewhere here it will go. So that straight line will be going like this way. And this theta, that tan theta is what is dy by dx, and this is what is the slope m. So this equation y equal to mx plus c is called slope intercept form, because that's the length of intercept on y axis. So what is c here? C is nothing but y intercept. C is called y intercept. Intercept. Okay. That's a fundamental equation. Y equal to mx plus c is the equation of a straight line whose slope is m and y intercept is c. Clear? Yes. Then what? Then we can think of other way of writing this equation. So this is slope intercept form. This equation is called slope intercept form. Very, very famous equation, slope intercept form. First way to write. Now let us see um, slope intercept form. Point slope form. Point slope form. Point slope form means you know any one point on this x1 comma y1, and you also know the slope of this. Let us say slope is m. Slope you know. Slope means this tan theta you will be knowing. Okay. So how to then find equation? So suppose any general point, if I take x comma y, and if I try to take the slope delta y by delta x, that m is delta y by delta x, right? We can now calculate here delta y. So y minus y1 by x minus x1 is m. So y equal to y1 plus m times of x minus x1. This is what it is. This is the form, point slope form. So one point you know, and you know the slope, then you can write this equation, right? Then next, 2 point form. 2 point form. 2 point form means you know 2 points on this x1 comma y1 and x2 comma y2. And if I know 2 points, then definitely I can calculate slope first of all. Let us calculate slope delta y by delta x. Tan theta. So slope, which is m, which is tan theta, delta y by delta x, we can calculate y2 minus y1 by x2 minus x1. We can calculate slope. Once we can calculate slope, we can use 1 point form. Point slope form we can use. So y is equal to y1 plus slope. Slope I will substitute it y2 minus y1 by x2 minus x1. Substitute x minus x1. That's how we can write this equation. 2 point form. Right? 2 point form. Then what else? We have double intercept form also. Let us write in terms of double intercept. Double intercept form. So if there is a line which is having intercept on x-axis as a and on y-axis as b, then this equation is x by a plus y by b is equal to. We can prove it also, but I am not going into that. You can easily prove it. Because if now you can very little, let us take one point as a comma 0 here, and this, let us say this is theta. So its slope, what will be its slope? Slope will be minus tan theta. Remember, this side it is minus tan theta. So slope you will write as minus b by a. So now you know slope. Now you know point. Use slope point form. So you can write y minus y1 is equal to m times of x minus x1. So just solve this, right? So ay is equal to minus bx plus ab. So from here bx plus ay is equal to ab. Divide by ab. So x by a plus y by b is equal to 1. Right? We can prove it. It's not very difficult. So all these things can be proved. Then normal form is a very good form. Sometimes it can be used in calculation. Normal form. Normal. Last. Normal form. What is normal form means? Suppose this is x and y axis, and suppose that this is a line, and suppose you know the length of perpendicular, let us say p, and you know the slope alpha of this. Then how can we write this equation? There is a form. Remember, I have given in the class, but let us try to see it. So can we find out this? No. Try to do this. How to calculate? Do you remember the entire form of this? P cos alpha something was there. X cos alpha plus y sin alpha is equal to P. Is that equation? Huh? What doubt? X and y is any point on this line. Any point means any point. Hmm. Which point? See, what is x, y means any point on this line. Try to understand. X and y are variable. Any point on this line. Now tell me which point should I put it. Tell. No, no, you need to put any point on this line. Do you know the equation of line? You don't know, na. You cannot put any random point. You need to put any point on this line. So tell me, any point do you know on this line? We will try to put it. You know this point, na? This point a comma 0 is on this, and this point 0 comma b, you know. You try to substitute that and satisfy. It will satisfy. Substitute. Or you can take any midpoint of this also. Midpoint also you can take. That means 0 plus a by 2. A by 2 comma b by 2 also you can substitute. Any point on this line which you know, you can substitute and check this. If you do not know, then why will you substitute, right? Then normal form means, you remember what was the form I gave? Do you remember this normal form? I forgot. I think I have given x cos alpha plus y sin alpha is equal to p. Check whether I have given this equation. If you have the formula, otherwise we can derive it. It's not difficult. This point is 0, 0 anyway. This is p. So this point we can definitely choose on this because this is p cos alpha, p sin alpha. So this will become p cos alpha, p sin alpha, right? And because this alpha, this is 90 degrees. This is 90 minus alpha. This is 90 minus alpha. So the slope of this line will become minus of tan 90 minus alpha, right? Minus of this angle. So tan 90 minus alpha will become cot alpha, correct? That's the slope of this. And now you know this point, and now you know this. Let us write this y minus y1, y minus p sin alpha, y minus y1 is equal to m times slope is minus cot alpha, m times x minus x1, x minus p cos alpha. Try to open this and check that. So y minus p sin alpha, open this. If I open this, it becomes minus x cot alpha minus minus plus p cot cot is cos by sin, so it will become cos square alpha divided by sin alpha. Then let us bring x and y one side or take LCM here. LCM also can be taken. But cot I can write again as cos by sin. Okay, so let us write this as cos alpha by sin alpha and take sin alpha LCM. So this will become minus cos alpha plus p cos square alpha. This sin alpha I have to multiply this side cross multiply. So I will multiply y sin alpha minus p sin square alpha is equal to minus x cos alpha plus p cos square alpha. So now bring x this side. So x cos alpha plus y sin alpha is equal to p sin square alpha plus p cos square alpha. If you take p common, so sin square plus cos square 1, so that's what it is, x cos alpha plus y sin alpha. That's what the equation is. Better remember this. Okay. X cos alpha plus y sin alpha is equal to p. So I think now we are done with the straight line. And also one important formula in a straight line is angle between two straight lines. Okay. Angle between two straight lines. Angle between two straight lines. So if you take two lines like this, okay, and let us say this line has slope m1, this has slope m2. So let us say one angle is theta, another angle is 180 minus theta. So any of these angles you can calculate. Let me calculate tan theta. So I can calculate as m1 minus m2 by 1 plus m1 m2. This is the formula, and we'll put its magnitude because we can get acute angle. So theta is the acute angle, so it is positive. Otherwise you can take minus also, so other angle will be obtuse angle. Right, so that's how we'll calculate angle. And note here that if the lines are perpendicular, so if theta becomes 90 degree, so tan theta will become infinity. Infinity means this denominator has to be 0. Denominator becomes 0 means product of the slope becomes minus 1. That's the important idea. If two lines are perpendicular, the product of the slope is minus 1. And if the two lines are parallel, then their slope must be equal. Okay. If theta is 0 or 180 degree, then m1 is equal to m2. So this is the concept if two lines are parallel, and this is the concept when two lines are perpendicular. Otherwise, other angles you can calculate from here. Right? done. Then lines is over, I think. Then we are going into the other kind of figures like parabola, hyperbola, ellipse. These things will go, and then we'll wind up this coordinate geometry will be over. Of course, in more detailed coordinate geometry, we'll be studying in maths in conic sections. Conic sections, I think in grade 12 it will be conic sections. So in 11 it is. Okay. 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 Then it is good only. Okay. Then let us start other kind of thing. Parabola. Let us start parabola. Parabola. Parabola equations is in this form. Let us write first form y square is equal to 4ax form. So this kind of parabola represents like this type of graph, like this. And this x-axis is the axis of parabola. X-axis is axis of parabola. Origin 0 comma 0 is the vertex of this. This is the vertex of parabola. And there is a point called focus, which is a comma 0. A comma 0 is called focus of parabola. Focus of parabola, like this. Okay. How is, by the way, how it is defined? How is parabola defined? What is the definition of this? Any idea? How is parabola defined? I think this definition of parabola is no. Definition means just like the straight line was defined. No. 1 minute. I'll check and I'll tell. Because parabola definition is based on the distance from directrix and focus. Okay. So of course in maths if you go then it is too much, but I don't want to go into maths more because maths I don't know that much in detail. But anyway, I'll try to give whatever basic. So suppose there is a line which is called directrix. Directrix it is. Okay, and this line is at a distance of a this side. Okay, so this line equation is x is equal to minus. This line is called directrix. So how this is defined? Let us take any point P here, x comma y. How is x y related? So the distance of this point from this directrix and distance of this point from this, these two distances are equal. Let us call this as L. L is the perpendicular line. So this point P and L is this distance is equal to P. That's what is the definition of parabola. So parabola is the equation. It's the locus of that point which moves in such a way that its distance from a fixed line and its distance from a fixed point are equal. That's how it is defined. You understanding this? Any point on this, note that it can be any point. Suppose, for example, I take the point here. So this distance, of course, here this distance is equal to A. Here this distance is equal to A. They are equal. But when you take any other points here, this may not be equal A, but they will be something else. But they will always be equal. That is the idea. So this distance will always be equal to this distance. Suppose if I take any other point here, this distance is always equal to this distance. That is the idea. Okay. Then we can prove it, but I am not going into detail of the definition of this. Okay, let us not go into more detail, but what is important for us to note that this is the equation of parabola y square equal to 4x. This equation is bending towards the positive x-axis, right? And this is the focus a comma 0. Now here we should note that there are four such standard forms. One is this way, another will bend like this way, another will bend up, another will bend below. Right? All those things can be, we can definitely do it. Let us do all those four forms. Let us do that. So second form is like this is y and this is x axis. Second form of equation is like this, bending in this manner, this way. So in this case, negative x-axis is the axis of parabola. Negative x-axis. Negative x-axis is the axis of parabola. Axis of parabola. And focus, now focus will be somewhere here. This focus will be minus a comma 0. Here the directrix will be here. Directrix is a fixed line. That directrix equation will be x is equal to a here. Okay. Again, the same definition is there. Any point on this point distance from focus and from this line, these two line length are equal. Okay. This point is PF and PL, let us say. So PL distance and PF distance, they will be equal. So what is the equation of this parabola? This parabola equation is y square is equal to minus 4ax. These are standard parabola. Again here origin is the vertex of this parabola. Origin vertex, negative x-axis is the axis of parabola. Parabola is bending in this way. Right? What are other two forms of this parabola? Other two forms are also there where y-axis is the axis. So if you take positive y-axis as the axis of parabola, then you can draw this parabola like this. Okay. So in this case, positive y-axis is the axis. Positive y-axis is the axis of parabola. Origin is still the vertex only, but focus will be now here. Focus here is 0 comma a 0 comma a and directrix will go down now. This directrix is y comma y equal to minus 2. Again the definition is same. Any point on this parabola is such that the distance from focus and distance from this is equal. So PL is equal to PF. P is a variable here, x comma y. So we can definitely write down the equation of that. Another type of, so what is the equation of this parabola? This parabola equation is x square is equal to 4ay. This form it is. Next, the fourth form it is the negative y-axis is the axis of the parabola. That's the last form, but I will also tell how to write the form of any other parabola. So here negative y-axis is the axis of parabola. Negative, and this point is 0 comma 0. Then where is the focus? Focus is here, 0 comma minus c. This is focus and directrix is this, y is equal to a. And again the same definition is equal here. Any point to take p x comma y, its distance from focus and its distance from directrix pl, they are always equal. Pl is always equal to pf. Right? So this equation of parabola is y square is equal to minus 4ax. Right? So these are four standard form of parabola. In all these standard form, you can see that if x is quadratic, y is linear. If x is quadratic, y is linear, or y is linear, x is quadratic. Like that you will see. So if you can bring the equation in any of this form, then you can compare that. Okay. And one of the important thing is that how can we write the equation of a parabola, or we can shift the equation of parabola. We have none. See that equation of parabola na. Tell me y is equal to x tan theta minus half gx square by u square cos square theta. Which parabola does it represent out of these four forms? So now try to you can try to bring in that form. Okay, it's possible to bring it. How to bring it? Try to bring it. Suppose if I take this factor common, I am going to take this factor as common. G by 2 u square cos square theta. So I will be left with x square here, and here minus will come, right? X tan theta is anyway there. Because I have taken this common, so I have to multiply this 2u square cos theta by g. Correct? Right? You can see that it is in this. So try to bring it. Let us now try to bring this. Y is equal to minus g by 2u square cos square theta. Let us write this as a square. So it is like a square minus 2 into a into b. Sin by cos, I think cos will get cancelled. So u square sin theta by g, I think it will remain here. Correct, na? Because 2 comes, x comes, u square, yes. So this is like a square minus 2ab plus b square. Let us write b square also. B square means power 4 you have to write. Right. So because if I write it like this, it will become a perfect quadratic equation, and I will subtract it also, so that there is no change in this equation. Right. Now this can be written as y is equal to minus g by 2 u square cos square theta. This I will rearrange it as x minus u square sin theta by g whole square. Yes, u square sin theta by g whole square. And this I will open this bracket. So if I open this bracket, minus minus will become plus. It will become, some factors will get cancelled. G factor will remain here. U square will remain here. Sin square cos square will become tan square. Uh, then 2 will remain in denominator. I think that's what it is. G got cancelled. U square will remain. Yeah, that's what it is. Now let us bring this side. See, bring this side. Y minus u square tan square theta by 2g is equal to minus g by 2u square cos square theta x minus u square sin theta by g whole square. Now look at this equation carefully. Which type of equation it looks? If you look at this equation, this looks like y. No, we need to x square is equal to 4ay now. Okay, bring x square one side. Okay, bring x square term left side. Okay, I will bring x square term this side. So x minus u square sine theta by g whole square is equal. This term I will take that side. So minus 2u square cos square theta by g into y minus u square tan square theta by 2g. Now you see here. So this side, left hand side is x square terms, right? Left hand side is x square terms. So I am writing this as capital X square. This is minus. This term I will write as minus 4a, and this term is 1. So this is like the standard form of which type? This type, correct? But only thing is that its vertex is not the origin. So what is its vertex? How do you know? You put this capital X is equal to 0 and put capital, uh, put that capital. So if you put this will be 0, and this point is going to be u squared sine theta by g, comma, that point also put y0. So you will be getting u square tan square theta by 2g, right? This is what it is. This is what we are getting. This is the vertex of this parabola. Okay, vertex of this parabola. Then what else? Axis is what? Axis of this parabola is negative y-axis, like this. Parallel to that, it's not that this axis is the negative, but this axis is parallel to the negative. That's what. So this, suppose they ask that this trajectory equation represent what is the vertex of that. That vertex, and note that it is not passing through origin. Is it passing through origin? No, this is not, because if you put x0, uh, this is not passing through origin. It's not the same kind of, which we are taking. So, mathematically we can do many calculations from it. That's what it is, right? Okay, done. Then what else? So this is, so what I was saying is that if you have a parabola, let us say this type of parabola equation which is in the form of y is equal to 4ax. This parabola is x-axis and y-axis. This is the origin 0, 0. But I want to write a similar kind of parabola with different vertex. Let us say like this. So this vertex, let us say is x0 comma y0. So this equation I can write as y minus y0 whole square is equal to 4ax minus x0. I will shift that. This is called shifting of parabola. This parabola has shifted so that its vertex has become different. Okay. So whenever you want to shift a parabola, we can shift it. So these are the applications. What about the other ellipse? Let us take ellipse and hyperbola. These two are important. Ellipse. What is ellipse? Ellipse is a curve, similarly x-axis and y-axis, and this curve is a oval shaped curve like this, and this point origin 0, 0. Standard form we are taking. This distance here to here is a. This distance is also a only. So this point coordinate is a, 0. This point coordinate is minus a, 0. Similarly, this distance is b. This is also b. This point is 0 comma b, this point is 0 comma minus b. Okay, so what is the equation of this? Equation is x squared by a squared plus y squared by b squared is 1. This is the standard form of ellipse where this 0, 0, this is the center of this ellipse, and ellipse has two focus, f and f dash, and this focus is ae comma 0 and minus ae comma 0. So what is ae? Ae is the distance from here to here. This distance is ae, or here to here focus distance is ae. So here this b square is equal to a square 1 minus e square. This relationship is there. E is called eccentricity. Eccentricity. E is called eccentricity, and the value of e is less than 1. Hmm. Yes. That is in a straight line, na? That is in a straight line. This is a straight, not like a straight line. It's a non-linear graph. Non-linear means curve it is. No, no, no. This double intercept form means a straight line. Double intercept means if a straight line is cutting that, you can make this equation of this straight line. Yes. Suppose if you make a line like this way, then AB, then that line equation will be x by a plus y by b equal to 1, right? That we can write it. And here this this x-axis is called major axis, and y-axis is called minor axis. Minor. And this distance length E is called semi-major axis. Semi-major axis length, and V is called semi-minor axis length. Okay, that's what it is. Then what else? So sometimes this ellipse can be like this way also, like this way also. Ellipse can. So the equation will remain same: x square by a square plus y square by b square is equal to 1. But the thing is that now this a is smaller than this. This is the case where a is smaller than b. So eccentricity will be defined as how? How to define the eccentricity is always less than 1, but a and b will interchange. So a square is equal to b square 1 minus e square we will write. Okay. A and b we will interchange in that form. Eccentricity will always be less than 1. Focus will shift now this side. This 0 0 origin is this center, but focus f will come here and f dash will come here. So this length will be 0 comma be, and this will be f dash will be 0 comma minus b. Okay. Here this y-axis has become major axis. X-axis has become minor axis. Okay, same way, right? Everything in A and B you have to interchange it. Which formula? No, 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 not like that. We don't have like that. We have to derive for each case. No, no, by practice you will memorize it. You have to practice it. Now it will practice. You start any book, NCRT or modules, but you go through the solve problems. Solve problem you go, and then you solve problem. Whichever basic level you can solve, that only you do it. Others you ask in the class. And tough problems are there. Okay, so this is ellipse. Then here also shifting can be done. Ellipse can be also shifted here. Suppose this is the ellipse, but its center is something else. X naught comma y naught is the center, right? And this distance is a, and this distance is b. This is also again a, and this is also b. So here x minus x naught whole square by a square plus y minus y naught whole square by b square is equal to 1. This is how we can shift the equation of this. Center is shifted now. Okay, done. That's what it is. Then we are going into hyperbola. 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 Huh. How much time is it? Finish the 5 minutes. Will finish it. Hyperbola. Last topic in this. Okay. So hyperbola equation is x square by a square minus y square by b square is equal to 1. That's all. So hyperbola will look like this way. This is x-axis, this is y-axis. So hyperbola. First of all, this is a symmetric graph. This is called asymptotes. This equation is like y equal to plus x, and this equation is y equal to minus x. So these two lines are called asymptotes. 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 And how is parabola equation looks like? Parabola equation looks like tangent to this asymptotes at infinity, like this one. This is how the equation looks like. And here, what is a and b if you ask? I think this point is a comma 0. This point is minus a comma 0. This is of course center of this. And there is a point here also 0 comma b. And here also there is a point 0 comma minus b. Here the focus goes this side or this side. So again it has two focus f of dash. This is a e comma 0. This is minus a e comma 0. And here you note that e is greater than 1, is greater than 1. So b square is equal to a square, e square minus 1. Like this type of equations. That's all. Rarely, I think we use in physics. Hardly we will use this. Maybe if you have got some equation and rearrange in this form, then you have to just tell that this is a hyperbola, right? And one important case is rectangular hyperbola. Rectangular hyperbola. In rectangular hyperbola, the asymptotes becomes the x-axis and y-axis. Y-axis, x-axis become asymptotes. So in this case, the graph of rectangular hyperbola will look like this, either this way or this way. And what is the equation of rectangular hyperbola? Rectangular hyperbola equation is x into y is a constant. X, y is constant, any constant it can be. This is a rectangular hyperbola. Okay, that's all. So we are done with coordinate geometry, I think, most of this. And anything else is remaining. One more point is remaining, I think. Distance of a point from line. Okay, suppose this is a point x1 comma y1, and this is a equation of line ax plus by plus c equal to 0. So distance of a point from a line, from a line. So if you drop a perpendicular distance, this distance is p, and this distance p can be calculated as magnitude of ax1 plus by1 plus c divided by root under a square plus b square. That's all it is. Might be this section formulas and other things are remaining, but those things are easy things, right? We have studied in your grade 10. Anyway, we'll see it with our tools, right? So done. So today we have covered this coordinate geometry. Next class will continue forward with that. Okay. Maybe some applications we'll see. We'll see applications in physics. Then we will move forward with that. Right? Then any doubt you have? Hmm, hmm. No, no, no. Same theory is there. For what you are asking for Newton's laws? What? Which case it is? According to question, we have to do that. According to question, we have to do that. Hmm. Which case? An example? No, no. Any case it is. Any case it is. It is not. No, no. Don't go by mugging up or all this. You have to just understand that. Okay. Otherwise, it will be very much a heavy task for you. Okay. Don't make it a heavy task. You take anything. Like take example. Tell any person, any situation. Okay. This is passing through a pulley on. Where? And this side is what? What is this side? Okay. Which direction he is pulling? Okay, so he is applying a force. A man is applying a force here, right? Then no. Velocity is different. Tension is force. He's pulling with velocity means he's moving it. He's moving it with this velocity. He's moving. That means this point which is holding is moving with velocity means this rope is every point on the rope is moving with the same velocity. Every point is moving with same velocity. Why it is moving? Because rope length cannot change. So every point on the rope will move with the same velocity, right? That's what it is. Every point, because if you pull it with velocity v, all points will move. Suppose it go 2 meter down, every point will move 2 meter down, right? That's what the speed will be same for each points. What? What are you studying? That is what is important. What are you studying? That is important. Are you studying the acceleration of this? Suppose you are studying the acceleration of this, then you have to study free body diagram. So on the block, forces are acting as tension and mg, right? And this body is going upward, so it has some acceleration upward. So if you apply Newton's laws, then tension minus mg is equal to mass into acceleration, right? That's the net force. That's how we write. Now if you see this point, this side point, because man is pulling it, right? So he has applied a force F. He has applied a force F on this rope. Now this point of the rope is, and if you see this point is also being pulled up by tension force, right? Because rope always pull a point, right? Or you may think like this: this man has given a force F to this rope, so rope will also give the same force to this man, right? Man will also experience the same force, which is nothing but tension only, because man will pull this person with the tension force, right? And so tension is equal to F only. Whatever is tension, that is equal to. So you may substitute here and calculate acceleration. F minus mg is equal to ma. So acceleration is equal to F by m minus g. That's the answer, acceleration. But if he is moving it with a constant speed, suppose he is moving, suppose if I take this as an instantaneous, then it's okay. But if he is moving with a constant speed, then there is no acceleration now. There is no acceleration. Hmm. Right? Then, hmm. See, that is what is relative now. Relative, I think you remember what is relative means. Suppose if there is a body is going with a velocity v, and another body is going with a velocity. This is v1 and this is v2, right? So suppose if observer is on this first body and he will not see himself moving, So that means he will add negative of his own velocity here, right? And then he is studying other any object he study, he will add his own negative. So he will add his own negative here also. Then he will see what? He will see the second body moving in the resultant direction of this. This is the resultant. This is what is velocity of 2 with respect to 1. So observer has to add his own negative to everything. So suppose he is under acceleration, so he will add his negative acceleration to any other object which he is studying. Okay. You take one alone, what difference it makes? Because see, the thing is that if you are studying this block, and this is wedge mass is m, okay, and this is a smooth surface. So when you want to study the actual velocity of the block, then you have to study, because they can ask velocity of the or acceleration of the block and acceleration of wedge they can ask, right? So that means with respect to ground, when they are actual velocity or actual acceleration, it is with respect to ground only they will ask, right? If they ask acceleration of the block, then it is complex, but relative is very easy to calculate, right? So relative means relative to this, it will slide only this way. That's what. So this acceleration is acceleration of, let us say this is first and this is second. This is acceleration of 2 with respect to 1. It is correct. That's what it is. But acceleration of 1, suppose as it is going down, it will be pushed backward. This is acceleration of 1 means this is with respect to ground, because with respect to ground it can only move this way, right? Horizontally only. But this second with respect to ground, how it will move, that is where it is complexity. That's why the first day we have solved that equation, and we have to remember that in order to quickly solve problems. That. Right. So, so don't focus on mugging up things, but try to understand for every situation what is the analysis, what do you want to do. Every analysis will have a goal, right? That you want to study this. That is why things are done like that. Because you have to study a particular thing, and in order to get that thing, you are doing all those formulas. Okay. So, mm, 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 mm. No, no, you are doing good only. Actually, getting 40 marks question where highest mark is like 50 or 55, I think it is, right? So that's a very good score. 40 means I think in physics we are fourth or fifth number, right? Hmm. But hmm, hmm. No, no, it is not possible to mug up all these formulas. But some standard formulas you can remember. Like this is a standard case. On a wedge, you keep a block, everything is smooth. What will be the acceleration of it? Because if you don't remember to derive itself, it will take a lot of time. Okay, like at wood machine, we should remember some important formulas we have to remember. But if then in different new situation comes, then we have to solve for that, right? So we need to understand the approach. Hmm. Yeah, yeah, we can apply that in any kind of Pulley problem. Any kind of Pulley problems, we can apply that. It will reduce all the calculations. Did you receive worksheets? I think they have. We have given them. They will be print out tomorrow. Okay, so you can start working out that worksheet. Also, module problems you work out. That will be sufficient. So whatever you are doing, it is good only, but try to clarify all the things, whatever doubts are there. If things become clear, then you can have a clear-cut idea of thinking about it. Right? That is important to develop, that clear-cut thinking, how to do, why to do. Then you can become independently, you can think about problems. Right? Hmm. Fine, that is sufficient. Okay, then we'll see. Okay, bye bye, good night.